Well, thank you for inviting me here. It's great to be here. It's really thanks to all the people like you who make it possible for us to do everything we do in space. Although, to be honest with you, in the very, very beginning, there was almost no computers at all in space, but these days we're completely dependent on them. I'm here not to talk about computers and computing or code developments. I don't know too much of that, although I did a bit of programming when I worked as a PhD a long time ago in Fortran, if everyone remembers that. So yeah, that's how old I am. I will talk about my experience, how I became an astronaut, and certainly about my space flights, a bit of doing the International Space Station, and then what I see the future for kind of space flights, what's happening now, in particular when it comes to human space flight. And I will say a few words about computers in between also, because I think you're interested in that. So, my background, I'm from Stockholm, just across the water there, a bit further north, and I grew up there, and I went to the Royal Institute of Technology, KTH, studying engineering physics. And I thought that was really fun, so I continued to study physics as a PhD student. But I always been in love with travel. Always loved to travel. It's exciting, and I actually took off a year, actually twice, for sailing across the Atlantic, which turned out to be a good idea when you applied for a job later. After I had my PhD, which was in experimental particle physics, I came to CERN outside Geneva, where I was working as a kind of postdoc a few years, studying the smaller things there are in the universe, the microparticles. I thought that was really fun when a friend of mine suddenly said, "Hey, Chris, I found a new job for you." "I don't need a new job." I said, "I'm doing research in physics. What can be more fun?" "Well," they said, "they're looking for astronauts." I thought he was joking, but the next day he gave me this ad he cut out of the newspaper. This was before the internet time. The European Space Agency looking for 10 astronauts. Wow, here was a chance to go to space. That was even cooler than doing research in physics. And at this time, I was 33 years old. I'd been thinking for quite some time that if I ever get the chance to space, I have to try to take it. So I went all in, made an application. Apparently it was good enough that I was at least invited to tests, interviews, medical tests, psychology tests, more interviews, a process which lasted actually for 2 full years, until in May 1992 I got the phone call. I had become one of Europe's only 6 new astronauts. And then it was very quickly. They wanted us to start already 2 weeks later at the European Astronaut Center outside Cologne. Barely did I get there until my new boss told me, "Hey, by the way, you probably have to go to Russia soon." Russia? No one had talked about Russia during these 2 years of interviews. But these were, when the Soviet Union just collapsed, and was an opportunity to work with Russia. One hoped that Russia would become democratic. Well, we know what happened now. But at the time, we hoped, and sure enough, I went to Russia just a year after Germany. And there I was training to go to the Russian space station Mir with this kind of Soyuz capsule. It was a lot of kind of training here. If we landed in the water, had to be able to jump out of the capsule with your spacesuit. But these were not the difficult stuff. Nah, the difficult things, that was the language. Everything was in Russian. We had no interpreters. All the books we got was in Russian. And I didn't know a word Russian when they told me to go to Russia first. We did get some training in Germany, but I was far enough to really understand in the beginning when they were telling us what we needed to know. So it was some frustration in the beginning, but finally I kind of learned Russian. I would speak decent Russian these days. And that's always nice when you work hard to overcome some obstacles, and then you feel good afterwards. Well, what was less fun was that I was not allowed to fly that, and then I was on the backup. And instead, after a while, I was sent to the US to Texas to Houston, where NASA has its astronaut center, the Johnson Space Center. And I became a member of the largest astronaut class NASA's ever had, and ever will have, I can promise you. We were 44, 9 of us, so-called foreigners, and became so crowded in the offices there that we got the class name the Sardines. But then someone got a very good slogan for us. For sardines, space is no problem. However, a very long line, as you can see, and who ended up at the very end of that line? The kind of younger version of me. So it took still some time before it was my turn to go to space. But although, of course, the ultimate for an astronaut is to go to space, it's still a very fun and interesting job all the time. And you work in very exciting environments. For example, I was training underwater because I was going to do spacewalks. And we trained that in water because you can kind of balance these spacesuits such that you don't float up, you don't sink down, you're neutral buoyant, and you can work around as you will do in space. And it's a very big pool, 60 meters by 30 meters by 12 meters, to house full-size modules of the space station and the shuttle at the time. Also did flying. Actually, one of the very first things I got to learn my first years in Germany was to take both a diving license and a flight license for future training. Although this very sleek jet aircraft, I was never allowed to fly myself. I was always a co-pilot here in the back. And by the way, down there right is a selfie even before the concept of selfie, using the old kind of cameras. Well, these airplanes were not only a training tool for astronauts, or is, by the way, in Houston. They're also used for transportation. As I said, we were living and training mainly in Houston, but the real stuff, that's over in Florida at the Kennedy Space Center. And when we needed to do some training there, we flew ourselves with these aircrafts. And indeed, when it finally came time to go to space for real, we, the crew, we flew ourselves with these aircrafts from Houston, and then we came to Cape Canaveral, Kennedy Space Center. We made a turn around the launch pad, and I took this photo myself of our shuttle Discovery waiting for us there. And then we landed on a very long runway just a few kilometers away, where the shuttles normally landed after a flight to space. And a few days later, the 10th of December 2000, well, it was 10th here in Europe, it was the 9th local time. We took our seats up in the shuttle. There were a few guys there at the top of the launch tower who helped us into our seats, and then closed this hatch, and then they went far away. No one want to be close when this starts, unless you're up there. And you're laying there on your back, not very comfortable, not much to do, a couple of hours. You maybe half sleep sometimes. But when these rockets start to move and sound, then you wake up for sure. You have 3 main engines. Take 6 seconds to get full speed on them, and then the booster starts. And you know, you go somewhere, hopefully all the way to space. I feel it. It's very powerful. That's about 2,000 tons goes to space. You can say it's about 50 million horsepower. But you can't point out when someone brags about this new car with a few hundred horsepower. It's shaky, both psychologically and physically. But mainly I was just happy, laughing in my spacesuit. After 14 and a half years as an astronaut, I was finally on my way to space. After 2 minutes, these boosters kind of done its job. They separated, fell down in the parachutes in Atlantic, could actually be reused. The shuttle continued, but after only 8.5 minutes, you are up in orbit, and the engines turns off, and you're in weightlessness, and a completely new way of life starts. 2 days after launch, we docked to the space station. which at the time was pretty much halfway built, with a crew of 3 guys there living. And our main job was to continue building the space station, which we did already the following day during the first spacewalk. And that was another wonderful feeling, just getting there out on outside the space station and float along on the sides. And here, that part we had with us in the shuttle, and was taken by robotic arms to the end of the space station at the time, and then we worked with it with this kind of battery-driven bolt drivers and put it in place. The following day, we were to retract some solar rays because they needed to be moved later. But as you can see, it didn't really retract as planned. So this became a problem which the Mission Control Center had to try to figure out the solution for. And while they were thinking, we were continuing up there doing what we had planned and trained for several years but at the time. This is during Spacewalk 2, where among other things we reconnected a lot of the electrical power system. And then it's always nice to tell your friends and acquaintances what you're doing. Maybe you recognize here the Swedish Crown Princess and live connection to Stockholm. I did a little frisbee trick to show what it could do, but unfortunately they didn't want to acknowledge it as a world record. They thought they were cheating doing it to weightlessness. Instead we got an order from ground control to say, hey guys, you better go out and make another spacewalk and fix these solar arrays. And that was a real challenge because no one knew the problem at the time. But together with really smart girls and guys who were working at the Mission Control Center, we succeeded. Here you can see it's retracted, and we could happily leave the space station. Here you can also see that's empty there in the payload bay on the shuttle where we had this piece with us to the space station. We still had a little bit of work to do in space, a couple of experiments which we sent out from the space shuttle. That one was to actually studying the remainder gases, or rather just single atoms, which are still up there on several hundred kilometers altitude. And 13 days after we left Florida, we are back there. Our commander did a perfect touchdown at this long runway which I mentioned before. And it was good he could do that, because the shuttle, when it came back, it was like a glider airplane, and very clumsy as such. You know, you only got one chance to land, but that always worked fine. But a few other things didn't always work fine, as you may know. Out of 135 launches, 2 flights of the space shuttle was complete catastrophes, and 7 people died each time. So the shuttle had to be retired, it wasn't robust enough, and never became cheap as was the plan. So after one finished building the space station for about 12 years ago, mainly finished at least, the shuttle has been retired. But anyhow, this mission was a fabulous mission. This photo was taken by our commander from the shuttle during the first spacewalk, and it ended up later at the website for travel. And someone called it the Travel Picture of the Year 2006. I can only agree. I didn't kind of invent that name, but I definitely agree. But funny thing is that also in a comment after that web page, someone had written that, oh no, that is too good to be true. It has to be photoshopping. But I know, I was there, so I know it's true. What you see there below us, by the way, is New Zealand, South Island, North Island. And it says it's called spacewalk. Well, you don't walk. You climb with your hands, and you see there are a lot of handrails. And like climbing in the mountains, we have safety wires in case you kind of lose your grip. So you don't fall down, but you get maybe lost in space. Now, it's a bit unfair that the astronauts get almost all the attention and credits, but there's hundreds, actually thousands of people behind every space mission. And in particular, there are many people working in the Mission Control Center like this. And they have a lot of computers with them, screens, checking every system. And there's one console for each system. And by the way, extravehicular activities, that's the NASA lingo for spacewalk. And there's a lot of information here. Here in the background is a map, for example, that shows where the station is at the moment, which satellites can it communicate with up in geostationary orbit and then down, and other things. But most interesting on this one here, I'm now in Denmark, I know, but still, look at that flag compared to that flag. I didn't plant it there, but somebody. By the way, I'm sure everyone from Denmark here knows that Andy Mogensen is right now on the space station, and soon will become the commander there from Denmark. Very cool. So a little bit about the computers on the spacecrafts. So this is how the shuttle looked like. This is how it looked like when I started training with the shuttle in 1996. And this is how it was later upgraded. But if you wanted to communicate with the shuttle, you basically typed here numbers and it would show here, and then you kind of entered it. But one interesting feature, though, is that the shuttle, it had actually 5 identical computers, pretty big and heavy ones. I mean, the shuttle was designed in the 70s and built in the early 80s. The first shuttle flew in 81. And the reason is that all the critical systems, you normally have at least 3 of them. Such as if you have 1 failure, you can still continue the mission. If you have 2 failures, you will still not die. You will at least be able to survive and come back. But the computers were assumed to be so critical that they actually made 5 of them, where 4 run identical software, but the 5th computer had a different software made by another company, but solving exactly the same problems and doing the same thing. And the reason was that if the thinking was that if there's a bug in there on the first software and it's not noticed until when you are really flying, then you can kind of fail back to the other software. So they didn't trust you guys. But they never had to actually make that fallback solution, so that always works. And here you can see a picture of the shuttle in space. That was my commander of my first flight, who took that fabulous photo you saw before, and that was the pilot. Somehow in shuttle lingo, pilot was what we normally would call the co-pilot. Well, the Soyuz, that was really old stuff. When I started to train in Russia, I trained with this one here. And it only had a memory of 256K bits. And there was even such that in some cases, most of your training is that you're trained to do if something goes wrong. And there was, I remember well, one failure case, if a sensor outside didn't work, you had to turn it off. Well, you did that. With a hexagonal code, you typed in an address here, and then you changed 1 bit in it, and then you turn it off. So that was another cool thing. Look at this. It was a hardware thing showing where you were on the globe. And if you needed to do an emergency landing, you just push the button there and you see where you would land if you kind of turn on the engines to brake. Well, I guess it was around 2000 or so when upgraded it, so now it looks a little bit more modern. This is still flying. The first Soyuz flew in 1967, and it's still flying. It had a few accidents in the very beginning, the very first one among them, but it hasn't had a bad accident since 71. Well, this is how the now most modern spacecraft flying to the space station look like. This is the SpaceX capsule Crew Dragon, and it looks much more flashy here on the inside. This is actually a photo from they were docking on the space station a couple of years ago. All right, now I'm going back to my own flights again. So after my first flight, I had a meeting with my top boss at the time, and he said roughly, okay, great job, Chrissy, we have another mission for you in the future, similar to what you just done, and that's it for you. Okay, fine. And he kept his promise. I got 1 more flight, but no more than that. But this is on my way out to my second launch. We are coming out, the crew, like my first flight. We flew 7 in a shuttle, but it was a completely different crew. out of the crew quarters, we've been living there for about a little bit more a week in quarantine, so we don't bring with us some bugs up to the space station. And then one went with this so-called astrovan to the launch site, to the rocket. And here's a photo from that launch. It was exactly midnight, almost exactly 14 years ago. Down here, it was the 28th of August, 2009. And some minutes later, over here, it was the 29th of August in Florida. And this shows not that we go up and crash down, it shows kind of dynamics in going to space. You need to get the speed high enough to go into orbit and not fall back. And that's about 28,000 kilometers per hour, 8 kilometers per second. And you cannot get that if you have air resistance. And that's why we go very high. We say that launch starts at 100 kilometers altitude, but in reality you need to go up to at least 200-300 kilometers altitude. And then you can start to get that speed. And it takes some while and distance. And then we follow the Earth, and everyone knows the Earth is round, and that's what you see there. 2 days later, now we are approaching the space station for the second time. And this is Nicole's Stott, which we are bringing with us. We're going to kind of exchange further on the space station to another crew member. And
Raw TCS,
here is one of the more exciting moments in the space flight, in addition to launch and landing. It's the docking.
Yeah, that's okay. Yeah.
So here you see the space station. This is the shuttle approaching, and that ring is going to connect in there. That's how we dock. The commander there, he's flying manually. Not too fast, not too slow, had to aim perfectly. All 7 of us on board are helping out one way or another on the flight deck. I'm there. I'm partly responsible for the docking system, partly focusing on camera, which he looks at. Actually, the station is upwards, but he's looking at that camera that we're seeing the docking port, showing how to...
Good closure.
Capture.
There's a light. We have capture, but we're still waiting for signals to verify. Okay.
You never got the contact in Houston from Discovery. Capture confirmed. Did we get it?
Got flashing red. All right.
And here we got that signal. Everyone is happy. In particular, the commander. Would have been very embarrassing for him if he had failed and had to go back. But it worked. And after verifying we were airtight between the shuttle and the station, we could open the hatch and float into the station, which now had a crew of 6 people, was almost fully assembled the station. And the commander there, Gennady Padalka from Russia, he's ringing the bell, which signifies it comes guests on board, which doesn't happen so often, so I think it's kind of fun. Gennady, by the way, he's the current world record holder in maximum time overall in space. So he has accumulated 878 days in space over 5 long missions. In addition to Gennady was one more Russian up there. There was 2 Americans. There was a Canadian, and it was a European colleague of mine, Frank de Wind there. So all in all, we were 13 astronauts from 5 different countries working together on this real International Space Station for a little bit over a week. Well, this time our main cargo we had in this module, which we connected to the space station temporarily while we were there. In there were tons of stuff, and much of it in bags like this. Is how we could kind of make a little langakedjor in Swedish, chain to kind of unpack. And here the stuff goes into the Japanese laboratory. So in addition, we had food and clothes and things like that to the crew up there. We also had a lot of things for science. After all, it's a laboratory. And one experiment was a bit particular, and it was this: in that box, which we had to have then in the cabin on the shuttle, there were 6 mice. We're going to study how the bones of the mice kind of deteriorates in weightlessness. That happens to us humans, and we need to understand this better to find countermeasures. Here I do my first spacewalk in this flight. That box I held there weighs about 850 kilograms. So I like to brag, you have to be strong. Okay, it was weightlessness, but still you have to control it in weightlessness. Frank DeWin showing how you can handle things in weightlessness as well. And he, by the way, became later the first commander on the space station who came neither from Russia nor from US. So US and Russia are the two countries who kind of owns most of the space station, therefore also have most of the astronauts. And the other partners are Japan, ESA, Europe, 10 countries there, and Canada. Well, Nicole, showing how fun you can have here in weightlessness once you get used to it. Otherwise, it's maybe not doing in the beginning. New kind of bunny jumping. The last evening, we gathered all 13 of us around one of the small tables on the space station for a little farewell dinner. And down there you can see how typical food is. I mean, it's in packets like that and tins, and you eat straight out of them. You can bring a bit of your own food with you. These are Swedish cookies, and so it's fun to kind of treat your friends from somewhere home, well, if they can catch it. And a final farewell toast. What we toast there is mainly urine, actually. So it's kind of recycled, so clean, I can drink it again. And then we left space station, and I got maybe the most kind of emotional views of the space station. We flew with the shuttle on 200 meters altitude, distance from it, and see this wonderful construction floating there 350 kilometers above Earth, like a super modern sail ship. And I had so fun. I was so proud of being part of building it. And as I mentioned to you before, I had been told I wouldn't be able to come back, so that was a little bit sad. But in general, it's been such a fun thing, and I'm so glad, so I can't blame him too much. Anyhow, this is a really fabulous construction which has been built and together up in space like a huge Lego. Lego, well, that makes it good here in Denmark. Piece by piece, over many years. The first part, that one there, was launched at the end of 1998. 2 years later, in November 2000, was big enough that it could have a permanent crew. So people have been living there continuously now for almost 23 years. In the beginning, about 3 people, then 6 people normally, and now 7 people normally. Why these numbers? Well, it's because the crew up there, they always have a capsule with them, such that if something happens, you can jump into that capsule and return back within an hour, or immediately, basically. And in the beginning, it was always the Soyuz. First 1 and then 2. And then now, in addition to Soyuz, you can use this Crew Dragon, which can take 4 people, whereas Soyuz takes 3 people. Now, these capsules are, after all, quite expensive. You don't want to waste them. And they can stay in space at least half a year. And therefore, people who live on a space station, they are there typically for 6 months at a time. So I made 2 short visits to space, about 2 each of them. But people there, they live up there. It's big. This is a bit over 100 meters wide. That's about 80 meters long. And inside these cylinders where people live, it's normal atmospheres. You don't need spacesuits there, as you already seen in the figures. Okay, again, back to the computers. How do you control the space station? Well, it's computer controlled. So there are 50, it's called computers or MDMs, kind of processors based on, as you see, an 386 processors. So the space station was designed in the 90s. And once you have something working, you don't change it. And they're all, as I said, everything critical is doubled or tripled. So if this is the kind of central computer, it talks to all the others, and it's 3 of them. And they talk via military buses, 1553. But these days, there's also Ethernet and fiber and Wi-Fi and things talking around. So the 50, what I call computers there, those are the critical ones for running the space station. And if the crew want to talk to them, well, they talk with them through a laptop, and they can kind of look at sensors or give commands. But normally, it's the mission control center. They do everything for the space station, which they can be done remotely. And that is done then by kind of radio connection, S-band, Ku-band. Now, then there's another 100 laptops which are spread all over for controlling the experiments, for the crew to talk to ground, to their relatives or love families and things like that. There's very, very many of them. And finally, each module has a so-called caution and warning panel, so that something happens, you're always close to hear that, okay, so something going on here, warning, and you can react to it. Actually, all over the space station, there's around 350,000 sensors who's sensing every single piece of how the kind of space station is doing and what's going on with it. Of course, the crew doesn't look at those, but in the mission control center, that's where the people are sitting, and they are looking at it all the time and see if something needs to be done. And then they normally tell the crew, okay, we are going now to get this command, don't be afraid. So, that was a little bit more about computers here. Let's go back to what we really do in the space station. So, the space station has been partly built because we want to learn how it is to build in space, live in space, and prepare what we need to know for going further in space in the future. But it also gives unique possibilities to doing research and science. It's not only the views, you get better views upwards and on the Earth, but the weightlessness, the long-time weightlessness, you weightless all the time, that can be used to do science in unique ways, in a very broad fields of science. From physics to biology to medicine. Just an example here. A candle looks like that because warm air is lighter than cold air. So the air here kind of goes upwards, and you get an air circulation, convection going. While in weightlessness, it doesn't matter that the warm air is lighter. It will just diffuse out, and you don't get as much fresh oxygen coming in, so it burns another color. I mentioned we had mice with us, also study how things are growing. But for astronauts, the most time is probably spent to research for the humans. We are both guinea pigs and operators. And unfortunately, most of our systems in the body, most of them, actually many of our systems in the bodies are affected by weightlessness, negatively mainly. And we need to understand that and find countermeasures. And even how you kind of psychologically interpret things and like that gets a bit affected in weightlessness. And so there's an experiment where Paolo Nespoli from Italy is going to do some EEG as well. Well, this photo of mine, these two photos of me also shows another effect going to space. Well, this is me just before my second flight. I started to get a little bit old and get wrinkles in my face. Well, a couple of days later in space, and many of the wrinkles are gone. You look younger. Unfortunately, the effect doesn't last to get back on that. But the reason for this is that here on ground, the weight draws the bodily fluids down in our legs. That doesn't happen in space, so the fluids kind of shifts upwards. And you get more fluffy in your face. And you may look nicer, but it doesn't feel nicer. It feels like you may have a little bit of cold. Another thing which happens in space is that you don't have the normal signals in your vestibular system, the balance system, because they normally, some of the sensors need gravity. So you kind of, you are out of balance when you get back, you're untrained. And this was an experiment I did, was no fun at all, I tell you. To kind of test how your balance system readapts when you get back to Earth. But for a couple of days, you walk a little bit wobbly, like you had a beer or two too many. But indeed, these kind of experiments have helped scientists understand a few new things of how our humans' balance systems or vestibular system works. And so we do this research not only to kind of find what we need to know before people can go even longer and further in space, but we also learn new things of our bodies, which we can use to help people here on Earth to have various medical problems. So a bit about living in space. We try to do a lot of develop methods to kind of live very sustainable up there, such that we don't need to bring up so much resources, because after all, that is expensive. And again, when we go further away to the moon and the Mars, it will be even harder to kind of send resources. So we try to kind of find ways to reuse. And we even do some research here to grow food, not because the crew is getting hungry up there, but for the future. That's what you see up there is the first crop of salad some years ago, actually. But he wasn't allowed, Stephen Swanson, he wasn't allowed to eat it. The first one they had to get down on ground to analyze it was okay, but it was okay. So now they do some tomatoes and salad, and they eat it sometimes. So to then reuse, as I mentioned, it's a pretty sophisticated life support system, which is close to some extent. That is to say, you drink water, you get water in your food, it comes out various ways, and most of the water comes out. You can collect it from urine or from condensation, and you clean it and you can use it again. Also, oxygen. We breathe oxygen, and then we exhale carbon dioxide, and we try to get the oxygen back from the carbon dioxide. And if you just have energy, you can do this, but of course you're limited in energy up there as well. But water has now reached almost 98% of recyclability, which is quite amazing. However, when we need to go very far away to the Mars, it will take at least a year and a half back and forth. And you cannot send spare parts. On the space station, you can get spare parts up there within a couple of weeks. Or you can get the crew back if it's really bad in a few hours. But when you go very far away, then you have to ensure that these things doesn't break over that long time. Or you can repair it. What you see there is actually one of my sardine friends, Jeff Williams. He has to repair this urine recovery system. He doesn't look unhappy for that, but well, these things must not happen going far away. Or you need to bring spare parts, but that's heavy. Although one of the future ways to solve it is actually to look into 3D printing, and that is tried now on the space station. It's a challenge to do that in weightlessness, because normally the powder or whatever you're using falls down and you process it. In weightlessness, it's more challenge, but they're working on it. That's Samantha Cristoforetti there from Italy. And the 3D printing on space station is using plastic. That's kind of learning, but for real difficult stuff, you would need something which is metal as well. A bit about the normal living in space. Like on Earth, you sleep, of course, about the same amount. I thought it was a bit difficult to get used to fall asleep in space, in weightlessness, when I couldn't feel the bed. I like to kind of lay on the back for a few minutes, and then I turn around and I fall asleep very quickly, feel the bed. Well, in weightlessness, you don't feel the bed whatever you do, you're just floating. But it's good you can put yourself wherever. On the space shuttle, we were 7 people sleeping in the same little volume. And it's good, like we could be sleeping along the walls, or like upside down in the ceiling, like a bath meter, and here they are on. Actually, that's where you go to the space station once you dock there. On the space station, the crews though have their own little cabin, or kayuta as Russians call it. And it looks rough like this, but with walls around here, But when I was there in 2009, one of the cabins still didn't have the doors. Actually, we brought it with us. And apparently it was the Canadian who had to sleep there because Canada is the smallest partner, they pay the least. But it was crowded on the shuttle, so once we docked, I took my stuff and made my own little campsite in the European laboratory Columbus, where no one sleeping. There was some rule you were not allowed to sleep there, but no one even remember why. So it was okay, and so I had my sleeping bag and a few things. And so I was asked, could I bring a few things with me to show what I had in space? So, well, some of the really coolest things, they are actually at the museum in Stockholm, the Technical Museum. There is a little exhibition of what I did in space. But so this little space troll there, which I got from my wife when I started training in Russia, was up with me. That's done that museum as the Frisbee. However, this book there I do have here. That is the so-called crew notebook. And there you kind of make your own notes from your training. And you can also put other things in there. Well, you have to have a photo from your family. With your family, that's always nice. Or I was doing some kind of game with ground in chess. So I made my own little chess, and since it wasn't weightlessness, I used Velcro stuff and all that. So I played a game against Sweden newspaper readers. I lost after a while, but it was still kind of fun. So here, that's a valuable thing. And of course, you also got to have very typical, your hygiene stuff. And the only reason I brought this one is that, as you see, these are Velcro clips here. So everything just floats around. So you cannot place things on the table, right? So there are Velcro on the walls, on the ceilings, the floor, and then everything you need to use, you have also Velcro. And you just put it somewhere, for example. Well, I did also have another Frisbee with me, because I did a lot of Frisbee, which was one of the things I brought with me as a gift to someone. It's just the point. I haven't decided who's going to get that Frisbee. But it says, "Come fly with me," which I thought was kind of nice. A sweet thing was that there was a tradition that secretly the mission control and instructors and all that, they kind of asked your family members to kind of write something. And once you got into orbit and you start to look at the things you had put away, you found a little letter, Christer, and there you had some very nice things written from my 3 children here. Love you and things like that. So that's very nice. So you couldn't bring much with you in space, but a few things. And here are a few things I promised to bring with me. So going further, then we talked about hygiene with this combat. So example, I have all my hygiene things from space still left. I couldn't bring everything with me. So the biggest problem with doing hygiene in space, well, there's 2, but one of them is there's no shower. And so it's a cheap hotel. No, but the biggest problem is that it's very hard to make a shower when the water doesn't fall down. So how would you take care of it? Well, you have a little towel like that. You can put some water on it, and then you kind of clean yourself. And here you can see how all the Velcro things are. You just push things on there, as I mentioned. Now, if you live on a space station for a long time, 6 months, you probably have to cut your hair now and then. And then you have to think about that if you cut the hair, the hair doesn't fall down on the floor. It will just float out and risk getting in your eyes or nose. So here, this is Tim and Nicole cutting the hair of Raman, and they have connected a vacuum cleaner hose to the scissor to kind of suck up. So a lot of complications living in space. exercise is always important, but it's even more critical when you are in weightlessness because your muscles and your bones deteriorate very quickly because you don't get the least natural training. Even when you sit in chairs, you kind of use some muscles. So if you're up there for more than a month, you get on your daily schedule twice physical training. There are several various exercise equipments. For example, here is a treadmill, but you have to then kind of connect you with some tether there so you don't float away when you run. Or this one here, which is for strength training. Normally we use weights for that, but in weightlessness that's useless. So this thing here uses hydraulics resistance and things like that to kind of give the same kind of resistance. And when that started to get up there, it wasn't there in the beginning. Astronauts comes back actually in a little bit better shape than before. And even on the shuttle, we had a little ergometer we could work out with, although 2 weeks time is not critical, but it's nice to do some exercise. I mentioned all of the food. The photo down right there is from the same dinner as the video was before. The food is the same kind of food as here. I mean, there's some meat and fish and pasta, vegetables, etc. It's that you cannot prepare it. You cannot boil, you cannot cook, fry. You can warm it a bit. A lot of food is in vacuum bags like that, and then you can push some water in there, which can be a bit warm, and it soaks up, and then you open it with a scissor and eat straight out of it. So I thought it was boring after 2 weeks. I just imagine what people think of it up there for 6 months, but still. Oh, no, you can play a bit with your food, which you're not supposed to do, but in a different way. If you want to drink, you take a bag and you can put water in it. Actually, here's the little pantry of the shuttle. You can do that. It could be some powder in that bag, which gives it some taste. Or you just let it, like if water float free instead of drinking out of the straw there. And you can give it some taste with candy from Sweden, in the shape of shuttles. That became a submarine, though. Normally, they have a shape of cars, but I got a special edition with me. And then...
Finns bara ett sätt att stoppa dem i munnen.
Sorry, that's Swedish. That was an old commercial in Sweden. Now, though, in addition to weightlessness, the very special thing up there is the views of space, of Earth from space. And you never get bored on that. It takes only 90 minutes to go one orbit around Earth when you're on the altitude of the space station nowadays about 400 kilometers. And when you've done one orbit, the Earth itself has turned a bit, and you see new things. And astronauts love to take photos. NASA actually puts on a website, an open website, all the photos astronauts are taking on Earth. And you can just go there and you Google your own town, or you search with your own town, and you can get many photos. Sometimes it's easy to recognize where you are, like this one here. I'm sure most of you recognize this, the Red Sea. Here's the Nile. But when north is not upwards and you don't really have a good idea of scale, it's a little bit tougher. But sometimes someone sees where this is. Yeah, exactly right. Gibraltar Strait, but that's Gibraltar's north is in this direction. Other times you just see fascinating colors and shapes in oceans, like this atoll outside Australia. You cannot see the Chinese wall. That's where you bear eyes. That's a kind of a myth. But you definitely see effects of human constructions. This is actually an artificial lake in Africa, in Cameroon. You see the river coming here, and there's another river there which is dammed up there. And that dam has created an artificial lake up in the river arms, and the sun is very low, giving this glint effect. Otherwise, it's really nighttime. You realize there's a civilization on this planet. And to me, it was almost the most fascinating when you're gliding over the kind of night sides of Earth. In particular, when it was areas you recognized well. It was like gliding on a huge map. I'm sure you recognize this one. Here is southern Italy with the heel and Sicily there, and the big blob up there. That's Naples. And have good eyes, you see a black circle in there. That's Vesuvius, which is a national park. You're not allowed to build there. You also get beautiful views of sunsets or sunrises. And you never have to wait a long time for this. You get 16 of each day. So, but this photo became really good. And here you see the rudder of the shuttle. But what really strikes you is how thin the atmosphere looks like, how fragile. That colored band there, that's about 100 kilometers, and it's only the 5%, the 5 kilometers closest to Earth, where we have enough oxygen. And most humans, humans and most animals need to live. And we need to be very careful. It's like we were very careful for the environment in our shuttle and the space station. If something goes wrong, we don't have much time to do something. Well, we do have more time here on Earth, but we do affect the atmosphere right now, and we need to be careful. Most emotional, though, is when you see your own home from space. I cannot brag I took this photo myself. I did see Stockholm from space, but just a little bit. But this photo was taken from the space station by Scott Kelly, another of my sardine friends, about 8 years ago. And he was lucky, as you can see, not a cloud all over Scandinavia. So right now we are here. And not only that, he also had the aurora there. I see I've been talking much too slow, but let's see how far we get. So I'm back home since about 10 years in Sweden, and I'm working still with space, and space is so much more than just human spaceflight. What people need to understand is how extremely important the infrastructure we have put up in space is for everyday life here on Earth today. We use it for communications, for making weather forecasts, or more in general for Earth's observation of any kind, both the civil and military, by the way. Navigation. I don't think young people know how to use a compass anymore. You just type in where you're going in this one, right? And then it tells you magically where you're going, thanks to signals from space. Signals we use extremely very high accuracy time signals. And those time signals are also used as free for many systems these days. Banking system, power systems, and others. And of course, we use space for research and science and inspiration. One should never underestimate the extreme importance, the powerful possibilities we inspire by going to space. We build satellites now, small and big, in thousands, and students build them. This is a student satellite at KTH, Royal Institute of Technology, where I work now, which we will soon launch. That's a typical size of a small satellite these days. And here you can see how the number of satellites per year we launch exploded a few years ago, mainly due to the huge constellation of communication satellites, which is now being put up there, in particular led by SpaceX and Starlink. Another interesting thing, and this is kind of coming in now to a little bit about coding again, and that is that all these Earth observation photos, which are taken from space, or just data taken from space, by using modern methods with AI and machine learning, you can optimize how you see things there. So this is, I think it's a Maxar company who trained the system to kind of automatically detect elephants on photos from space. So you don't have the human there looking at it. And then that can help keeping track of the elephants and hopefully also counteract on poachers. The next step, which is starting to happen, is that you don't bring the data down on Earth and then you analyze it. No, you put the analyzing on the satellite. And you need to be very smart, and because your satellite has quite a limitation on power consumptions. So that is some, if you want to go into kind of coding for space, think about that, how to kind of code satellites to just pick out the really interesting data and send that down to Earth, so you don't have to send everything, which is actually a big bottleneck today. Now, the key, though, to go into space, that is the rockets or launchers. And that big development ongoing, particularly reusable. I'm sure everyone's seen this. The Falcon 9 from SpaceX, first stage, coming back and landing like that on a barge often, but sometimes on the launch pad, and can be reused again. And this is done routinely these days. They about once or twice a week now they're sending up these, and they come back like that. And some of these have launched 10, 15 times. Now, but SpaceX and Elon Musk is not happy enough with that one. They want this one, the Starship with the booster super heavy, which will be able to take well over 100 tons to space. And everything will be reused. And this super heavy launcher booster will actually land here on the landing site. And when that succeeds, the cost to send things to space will drop drastically. Already it's dropped quite a lot with this one, but with that one, it would drop another factor 10 to 100. And we can start to use space in many, many more ways. Yeah, here's another couple of ways, new launchers. So what does this mean? Well, economists have started to look into this, and it's called the dawn of new age is starting here now, that today the value of space business is somewhere, depending on who estimates, about 400 million. Citibank thought, Space Foundation 550 billion, but everyone says it's going to rise and it will reach $1 trillion, maybe 2040, maybe already 2035, there's an interesting kind of people want to invest into that. Of course, the human spaceflight, that is, after all, the coolest, right? So let's finish with a few words of the future of the human spaceflight. Well, we are on our way back to the moon, with humans also, not only the automatic landings like Russia no failed and India just succeeded at the South Pole. But since 10 years, we have a program, well, not really 10 years, but almost, a new program called Artemis, which is led by NASA, but otherwise the same partners as on the space station except Russia, who are kind of, the name is Artemis. Artemis is the sister of Apollo in the Greek mythology. And indeed, the explicit goal stated here is to put the first woman and the first person, non-white person on the moon. The official goal is 2024. Well, it was that, and then it was 25, but that is unrealistic. But 26, 27, probably a reasonable day. But this time, it's not only to put the American flag there. First of all, this is an international program. It is really to build up an infrastructure. This will be a station going around the moon called the Lunar Gateway. There will eventually be a base on the moon, on the South Pole most likely, because you get sun there all the time, almost all the time. That will be kind of gathering all the knowledge we need to eventually go to Mars. By the way, maybe you recognize this one there. That's the Starship. That is right now, or it is the ship which has been kind of agreed with NASA to be for the first lunar landing. And it's a very complicated thing. So they will launch with this rocket SLS, which is much too expensive, with Orion capsule, and then they will dock with this one in lunar orbit. Crew goes over here, and then they land, and then they go back up and all that. But there's some political reasons to this. But anyhow, the interesting is things are happening, infrastructure is going on. So Artemis 2, that's the name of the first human mission with humans going around the moon since 1972. And this is what they will see. This is a video, put together from Artemis 1, which flew a year ago, and how you see the Earth going behind the moon and coming back. That will, for humans, see again in a little bit over 1 year's time, towards the end of next year. And then a few years later, people will walk on the moon again. But it's only the beginning, only the next step. It's officially stated that the Artemis program to the moon is to prepare for going to Mars. And, but there's no timeline for that, unfortunately. But if you're optimistic, yeah, late 2030s. The interesting thing is that, you recognize this again? The Starship, SpaceX. The company SpaceX was founded by Elon Musk with a vision to send humans to Mars. He thought it was a necessity for humanity to be able to live there as well. And he thought NASA was going too slow. I'll do it myself. Everyone just laughed. Well, these days people doesn't laugh about that anymore. If this works well, yeah, he might be the first one to send humans to space, to Mars there. If you go into the office of SpaceX outside Los Angeles, this is what you see. That is so cool. You work in a company with a vision to terraform Mars. This is Mars today, and that is not the Earth. That is how Mars might look like Earth a few hundred years from now, if you get things going the right way. In between here, we will also start to build commercial space station around Earth. So ISS is said to continue to 2030, and then in 2031, it will be brought down, destructed in the atmosphere. The plan for NASA has is that there will be commercial space stations coming up in between, which will take over the activities needed to be done in low Earth orbit. And then they will pay these companies to kind of when they need to have astronauts there. And the two leading ones, there's two more in the US, are the Axiom Space, which is soon going to put a module on the ISS, and they put their station together there until the ISS going down, and then they undock, and they have this space station here. Orbital Reef is another one, which is several companies together, which will use expandable or inflatable modules, very cool, which you can blow up to do this. So these things are ongoing. It's very cool. And if you want to have the ultimate, well, you should look at the inspirational talk by Jeff Bezos, who is also a space fan and investing a lot of money into space with his Blue Origin company, a couple of years ago, where he talks about building a complete city in space in a torus like this, which rotates slowly, so you get the kind of official gravity there. Well, that is a little bit beyond what I think will happen in my lifetime, but the others, I hope. So, I don't know if you have time for questions. I wasn't maybe even planned for that. I'm sorry, I'm 4 minutes late, but thanks a lot for listening. I hope you will help us go to space. Thanks.